Now I will start up with the explanation of the chapter refraction. After reflection, we will discuss this topic. In the beginning of this refraction, I have just recapitulated the points which you already did in 10th standard, so I don't think so you will face any problem in the beginning of few pages. Come to page number 3, there is a derivation of principle of reversibility of light. This is a simple derivation in which they have shown that when light is going from medium 1 to 2 and going from medium 2 to 1, their refractive indexes are just the reciprocal of each other. It's a very simple proof, so please go through this and learn it. Then again two derivations are there which are again very important. I will start with the explanation of this. It is applications of refraction. First is apparent and real depth. This we have taken this example in 10th standard also. At that time we have not given any derivation to you to prove this. They said if you will, observer is standing outside the pool of the water and look into the pool, what he observe, according to him, if this is the deepest, this is the base of the pool, right? So to the observer outside the pool will appear to be little bit shallower. Means he will observe that its depth, its base is lying at point I, not at point O. So the pool will appear, a water tank appears shallower, that is less deeper than what it is actually to the observer which is standing outside the pool of the water or outside the tank of the water. So from here, if you will see that this, you can understand this in this way also, that if we keep one coin at the base of this tank at point O, and for the observer that coin will appear to be lying at point I, not at point O. For explaining this with the help of this diagram, the rays are going from O. One is going straight, it will pass as such because this is striking at 90 degree at this interface, right? Second is going slanting, so it will be bent like this away from the normal. When you will produce it, both the rays will meet at this point I. So I is your apparent point, right? This is the apparent image of the coin which will appear to this observer person standing outside the pool. So according to this diagram, this will be the apparent depth and this will be the actual depth, AO. So when you will develop a relation between these two, it means all this is happening because of the refraction, because of the bending of light at this interface. The person cannot see the actual position of the coin. According to him, the coin is lying at point I, but actually the coin is lying at point O. Similar is the situation with the depth of the pool. So when you will drive the expression, it's very simple steps are there, you can easily understand it. So what we have concluded, that refractive index of the denser medium with respect to rarer medium is equal to real depth divided by apparent depth. Then they have calculated the normal shift. Normal shift means how much it is raised. It is raised by this distance IO. So this IO is called the normal shift. This you can calculate here. It is again very simple. So second, same case they have discussed here. In the previous case, we discussed that if the observer is lying outside the water tank, like if observer is lying in the rarer medium. Now, if my observer is any swimmer which is inside the swimming pool, by standing inside, he is looking at outside the pool, then it means my observer is now in a denser medium and he is looking at the things which are in a rarer medium. Then what will be the situation? If the rays are going, like if my object is at a point P, object is lying at point P in a rarer medium, then rays are going like this. It is from rarer to denser medium, so they will bend here towards the normal and reach to my observer which is inside the water. So when you will produce these refracted rays backward, they will come to meet at point P dash. So to the observer which is in denser medium, which is in water, the position of P will be appear to be at position P dash. It means height appear to be raised. So over there, what was the situation? Over there, what we observed, the depth will be decreasing, but here what we observe, the height is increased. This is the actual height, this is the apparent height, and apparent height is greater than the real height, which you can explain from this diagram very easily. Very important topic next, which is usually asked in the paper also, is total internal reflection. For this, there are first of all two conditions. One condition, I will discuss the conditions later on. We will start from here, that if my object is lying in a denser medium, rays are going, one is perpendicular ray which will pass as such, then the second ray I'll send like this, right? According to the refraction, it should bend from away from the normal. Then I will change the angle of incidence, and for one particular then I change the angle of incidence, and what I observe that for one particular angle of incidence, which is called critical angle C, my refracted ray is going along the interface. See here, A to B to ray, it is going along this interface, means angle of refraction is 90 degree, right? Then I again change the angle of incidence. Now my angle of incidence is greater than this angle, critical angle. So what will happen? My ray will not undergo any refraction, but it will be reflected back in the same medium. This is called total internal reflection. What are two conditions for that? First condition is ray should go from denser to rarer medium. Second condition is your angle of incidence should be greater than a critical angle. So you have to learn the definition of critical angle, total internal reflection, and conditions also for this, right? So there is a simple derivation which will produce one formula for this, you can say, total internal reflection, which is very important. So they have discussed that case where our angle of refraction is 90 degrees, sin I by sin R is equal to refractive index of rarer medium with respect to denser medium, because rays are going from denser to rarer medium, right? So when you derive this, you will come to observe that this refractive index is equal to sine of C. C is the critical angle. So if I will take the reciprocal of its refractive index, it is 1 by sine C. So refractive index of denser medium with respect to rarer is 1 by sine C. This formula is very important. They said if your rarer medium is there and denser medium is any medium having refractive index nu, then this formula will take the form nu is equal to 1 by sine I C, right? So you have to learn this, the refractive index is inversely proportional to the critical angle.